Hi there. We're going to start the class of today. It's going to be about getting the volume of prisms and pyramids that have a base of a regular polygon. So for example, you have seen many of these pyramids like in Egypt from the movies perhaps, and they have a base that is pretty much a rectangle as you can see here. So I'm going to trace that invisible part, and it's going to be a rectangle on the bottom. But today we're going to see other shapes. We're going to see pyramids that have other bases. So for example, here's a base that is a of how many sides do you have here? 1, 2, 3, 4, 5, 6. 6 sides. That's going to be a hexagon, and this is going to be a hexagonal prism, and this is going to have 1, 2, 3, 4, 5, 6, 7, 8. This is also a prism, and it's going to be made up of base that is an octagon, so that makes it an octagonal prism. And this one has a bunch of sides. I'm not even going to start counting them, but this one, I mean, it's pretty easy to count. You got 1, 2, 3, 4, 5 sides. That's a pentagon. So this is going to be a pentagonal prism. How do we get the volume of such shapes? Well, before we get into it, where do we see chemical structures? Where do we see prisms? Well, if you look at your pencil right now, it's going to be made up of lead, and the lead is graphite. And if you look really closely with a nanoscope or some device that is stronger than a microscope, you're going to be able to see the molecules that makes up the structure, the chemical structure, and it's going to be like a prism that I just mentioned. And this structure is what gives it the shape of a pencil. But the same carbon, if you place it in some other configuration, some other geometrical configuration, such as this one, it's going to give you the same carbon can be used to make a diamond, like for a ring. So your pencil made up of carbon, if it's reconfigured geometrically into some other crystalline shape, it's going to become a diamond. Well, but it's all thanks to the geometry of the molecules. Alright, where else do we see these things? For example, here's a hexagon. I believe 1, 2, 3, 4, 5, 6. That's a hexagon. And this is part of a nanotube. And that's a prism, guys. We don't talk much about nanotubes today. It's still something in development. But in the future, nanotubes is going to be like what is today, maybe computers or something like that. It's going to be something that is going to be revolutionizing technology. And well, today it's just in research. But what I just want to tell you guys is that the molecular structure, it's in the shape of a hexagonal prism, and so on. Alrighty guys, let's continue. Now, how do we get the volume of a prism? Okay, so let's imagine that we have here a slice of bread that has an area of a pentagon. So that slice is going to have an area that we know how to get because we know the apothem, we know the side, and we know that it has 5 sides, and it's going to be pretty easy to get its area. We did that in the previous video. So that's going to be one of the sides. Well, that's going to be the base. Now, let's imagine that this is one huge loaf of bread. So that means that we have many slices. So each of the slices is going to have the same area as the one on the base, and so on. And we're going to keep doing this. We're going to keep slicing this pentagon, this prism, until we reach the top. And how many slices do we have? Well, that's going to be what you have here in the height, which is 30. So that means that all you have to do to get the volume of this shape, it's just multiply the area of the base times the height. Because the area of the base, it's like the amount of particles or the amount of space that you have in one slice, and the height tells you how many of those slices you have. So all you have to do is just take the formula of last class and then just enhance it with this h to multiply it with. And you do the same procedure as last time, and then divide by 2, and then so on, and that's going to be the volume of a pentagonal prism. Pretty easy, right? That's all you do. Now, how do we get the volume of a pyramid? Okay, before we get into that, I just want you to remind you that there's a rectangle-triangle relationship, which is going to be telling you how to get the area of a triangle. So we have here a rectangle, and if we slice it just there by the middle, what shape do we have here and what shape do we have here? Well, we got there two triangles. So that means that the area of a triangle, it's this area. Let's say that this area, this triangle, it's going to be the same as the area of the whole rectangle, but divided by 2. So that's going to be the way you can get the area of a triangle. I think I mentioned that a while ago, or maybe in the previous video. That's how the formula of the triangle is obtained. Well, something like that is going to happen when you have a cone. Let's watch this animation. So at the beginning we had this prism, but it got cut into several parts, actually into 3 parts. And as you can see, if you cut it into 3 parts, starting from one of the corners to the other vectors on the bottom of the prism, well, what shape do we have? We got, let's look at this. Well, we got one triangle. Well, it's one triangle here, and there's another triangle over there. Well, actually, that is going to be a pyramid. So we get 2 pyramids right there. Well, actually 3 pyramids. And what does this mean? Well, it means that in one prism you have 3 pyramids. Just like when you had one rectangle, you got 2 triangles. In the prism, you have 3 pyramids. That means that all you have to do in order to calculate the area of a pyramid is just divide the area of the prism. Yes, yes, no, no. Okay, that's what you do, guys. Okay, so that's pretty much what this is saying here. You take a pyramid, you take a prism, and then you slice it into 3 parts as we saw in the previous animation. And we're going to get 3 prisms that are, 3 pyramids that are exactly the same. Alrighty, so that means that if you want to get the volume of a pentagonal pyramid, you got to do the same thing as before. That's what you did in the previous slide over here. It's this formula: the height times the number of sides times the base times the apothem divided by 2. But now you gotta also divide everything here by 3. But remember the multiplication of fractions? You gotta multiply the numerators with the numerators, these with these, and then the denominators with the denominators. So this formula is going to be changed into this, which is going to be the height, the number of sides, the base, and the apothem. That's what you have right there. Now, I forgot to mention that we're going to change the names of some of these elements and the shape. So for example, I'm going to be starting to use, instead of using the H for the apothem, I'm going to be using the A for the apothem, and the H is going to be used for the height of this shape. In this case, it's a pyramid. So it's going to be height times number of sides times the length of one of the sides, like this, times the apothem, which is this part over here. And then you got to divide by 6. So that's going to be the big difference. Before, you had to divide by 2 because that would be the area of that pentagon or whatever shape you have, and then times height. But now you got to divide by 6 because it's going to be 1/3 of that volume formula, and 1/3 of that is going to be 3 times 2, it's 6. So you got to do that slight adjustment to get the volume of a pyramid. So this is going to be the formula to get the volume of a pyramid. And so let's do it for this one. Let's see, what do we have here? It says that we have, well, it doesn't say anything, but we gotta count how many sides we have. So it's going to be 1, 2, 3, 4, and 5. So it's going to be a pentagonal pyramid. That's why the N, where's the N? It's not there, but the N here has a length of 5. I mean, it has it's going to be having a value of 5. So the height is going to be 30, the B is going to be 12, and the apothem is going to be 6. Then you multiply all of this, you got to divide by 6, and you're done. Alright, so for those people, those students that love history, I got an example here for you guys. I had an example a while ago about chemistry, about technology, and stuff like that, but I also got an example for those that love history. So this is found in the Museum of Archaeology in Istanbul, Turkey, and this is going to be a heptagonal tablet. And if you read closely to what it says right here, it says that it's a school tablet in the form of a heptagonal prism which contains a list of professions. A school tablet. I don't know. I have no idea. I tried to research more about this example, but I found the picture and I found it very interesting, so I decided to put it here in the video, but I couldn't get much more information except what it's being said there in the legend. So I don't know, you can research what it means. I don't know why they have them in heptagonal form. They liked 7 sides, I guess. I have no idea. And they're tablets. And they used, I guess they were used by kids because it says a school tablet. Maybe it was used for professions back then. So why is it heptagonal? That's going to be the mission of one of you guys in the future if you become archaeologists or historians or something like that, and you want to get into the mysteries of the past. But what is important here for this class is that it's made in a heptagonal shape. Why is that? Again, I have no idea. Alrighty guys, so let's continue. Let's suppose that we want to calculate the volume of this shape. Let's say that we want to find the volume of a heptagonal prism because this has the shape of a heptagonal prism. Let's calculate its volume. Let's say that the height is going to be 20 centimeters. It's going to be from here to here. And it has an apothem of 9 centimeters, which is the length that goes from the center to the middle of one of the sides, and a side length of 12 centimeters, which is going to be from here to here. Okay, something like that. Okay, so that's going to be the side. So what do you do? It's always going to be like this. So it's going to be the height, which in this case it's 20, then times the number of sides. How do you know how many sides you have? Well, it depends on the name of it. If it's heptagonal, it means 7. In the other video, I showed you a list of the names for those shapes, for those regular polygons. And when it's heptagonal, it means that you have 7 sides. So you got 7 sides, and the base is going to be 12. The apothem is going to be 9. We're going to multiply that, and then we divide by 2. That's going to be the prism's volume. Alright, so let's continue with one more example. We have here a nonagonal pyramid. So that means that on the bottom of this shape, there's a nonagon that is that's going to be a polygon that has 9 sides. So okay, we can't see this side, but there's a side right there. So you got 1, 2, 3, 4, 5, 6, 7, 8, and 9. You get 9 sides. This makes it a nonagonal pyramid. How do we calculate the volume? What is inside this pyramid? How do we do that? Well, first we gotta know, well, of course, we just did it. How many sides we have? It's 9. So the n, we got it, it's 9. And it says it's a pyramid that has a height of 50 centimeters. So the height, which is from here to here, it says that it's going to be 50. That's what we have here. And then the base, or the length of one of the sides, which is in this case 7. And there's an apotheme of 15 centimeters. So that's going to be the length from here to here, somewhere around there. And we multiply and divide by 6. And that's it, guys. So if you have any doubts, any questions, you know where to find me. And that's it, guys. So you guys have a great day.